dear student, today we are solving RBI DSIM past year question. This is 11 number B. Consider the three-state Markov chain having TPM given below. So is that chain reducible, aperiodic, and find the stationary distribution for the above chain as well. So in this case, to analyze the Markov chain, we need to check the properties of the irreducibility and aperiodicity. So irreducibility is a Markov chain is said to be irreducible if it is possible to go from any state to any other state. So state 1I to state j. That's it. That's the possibility. And obviously you can come here I equal to any number. So the finite number, with it obviously any finite number of steps with non-zero probability. So there's a possibility. So if the given transition probability matrix, TPM is the transition probability matrix. Okay, we can observe that there is a non-zero probability is going on the state on the non. So for example, for state 0 here, so what happens for state 0? So we can go to state 1 with probability 1 by 3, and then from state 1 we can go to state 2 with the probability half. And from state 2 from state 1 to state 0, 1 to 0 we can go with the probability half, and 0 to 2 we can go with the probability of 1 by 3. From state 2 to 3 this is probability of half, and 0 to 1 is a probability of 1 by 3. So therefore the Markov chain is irreducible. So aperiodicity is a Markov chain said to be aperiodic if the greatest common. So second is aperiodic is GCD of the number of steps required to return to state 1 itself is 1. Okay, so if the given transition probability matrix, we can observe that there is a non-zero probability of remaining in the same step 1. Say for example, probability of remaining in state 0 after one step is 2 by 3. State 1 after one step is 0. State 2 after step 1 is also 0. So since the GCD of the number of steps required to return to step 1 is 1, so the Markov chain is aperiodic. So this is done. Now finding the stationary distribution also we have to go for that. So for an irreducible and aperiodic Markov chain, the stationary distribution exists, okay, and is unique. So here we need to solve the system of linear equations. So here we can take it pi as a row vector, pi this part. So pi is pi 0, pi 1 and pi 2. So this represents the probabilities of beings at state 0, state 1 and state 2 respectively, and in the stationary distribution substituting the given TPM we can see that so pi equal to pi p. So pi 0 is 2 by 3, pi 0 half, pi 1 pi 2. Similarly pi 1 is 1/3, pi 0 half, pi 2, and pi 2 is half, pi 1 half, pi 2. So additionally we have the condition that the sum of probability in the stationary distribution should be equal to 1. So this is pi 0 plus pi 1 plus pi 2 equal to 1. Solving this system we will get it as pi 0, pi 1 and pi 2 is equal to 1 by 3. So therefore the stationary distribution for the given Markov chain is 1/3 for all. and the probability of being at any of these three states is also 1 by 3. And that's the end of this long and